When I was 17, my brain forgot how to walk and I was paralyzed. This transformative experience led me down the path of psychology and neuroscience, in an attempt to understand how our brain works or why it sometimes fails us. The brain is made up of billions of tiny wires called neurons. These neurons communicate with each other all the time to make sure we function properly, whether we're adding up our taxes or simply putting one foot in front of the other. They work together so well that out of a jumbled collections of wires and cells emerges a conscious, intelligent human being. We don't really know how these interactions give rise to such phenomenon, yet scientists and engineers have endeavored to replicate this behavior for decades in fields such as artificial intelligence. However, even now, our best AI models require tremendous amounts of energy and data to replicate intelligent behaviors that a 3-year-old child can sometimes learn in a day. Many of these behaviors can't even be reproduced at all, even by our most advanced technology. In my PhD, I've helped build an artificial brain made up of tiny wires that are similar to neurons, called nanowires. They look alike, and they also communicate in a very similar way. This brain, called a neuromorphic nanowire network, can implement certain AI tasks with dramatically reduced power requirements due to its similarities with biological brains. We can also test types of behaviors that conventional AI performs really badly on, such as time series analysis or noisy data processing. My specific research looks at changing the shape and structures of these nanowires to see how this impacts certain behaviors. This helps me understand better how neural structures in the real brain work together to create intelligence. Furthermore, if neurons in the real brain are damaged by something like neurological disease, my research may help replace them with nanowires from the artificial brain to make up for their function. So I was lucky enough to regain the ability to walk naturally, but it's my hope that through my research, I can help others who are not as lucky as I was.